It's arm day. Okay, so now we're going to print the arm out. You can load up your plate like some people do and just print all at once, or you can do it like I do, which is to make smaller groups of parts together and print them out in series. It reduces the rate of failure. In terms of layer height, we're going to be doing 0.1, 2, and below, also known as super quality in Kira. In terms of the orientation, everything is already pre-oriented to make sure that you get the optimal results from your print. But if you want to change them, do what you need to do. The following parts listed above will need the specified percentages of infill. Because they are the wear and tear parts of the Caractacus, they need a little extra. Otherwise, everything else can just be the usual 20 to 25%. Additionally, the following parts will require supports. The rest of the parts do not. Slight tangent. The hydraulic pistons, I like to do them in silk PLA because they make a nice metallic color, and instead of painting them and watching the paint rub off, this will actually retain its surface and finish, and it looks really sharp. And here it all is. As you can see, I've got my tools of choice here. One thing you will need is this 1.75mm drill bit and hand drill. You will need these 6 30-second by 3/8 of an inch screws and nuts, and of course some filament and TPU filament. Here's a small video on how the arm is assembled. Some parts are a snap fit, like the elbow pad or the ball socket for the bicep strut that goes into the shoulder. Otherwise, everything else will have to be cross-pinned with PLA filament. Okay, so all of these will need to be drilled out. Every hole needs to be drilled out. This particular area will probably need to be sanded, as well as this area for better fit and movement. For this, I like to use a calibration cube to support the bicep strut while putting in the ball detents, but with a pair of pliers, it makes easy work of it. So here we see we've got all our parts put together now. Now we're going to use some 320 sandpaper to just polish this ball a little bit so that it's smoother. Otherwise it won't fit in probably because of the rough edges. Layer lines will do that. Once polished, it should snap in and have a good amount of resistance to move around. Now when this wears out, you're going to need some TPU. That is the elastomer that adds the pressure back into the joint and makes it last much, much longer. To give you an example of how this works, this is the new joint right here, and this is the joint from my previous model that I've had around for a long time. You'll notice with the new joint, it has a good amount of resistance and plenty of wear to go. If I put it into the old joint, observe, see how loose that is? But just by virtue of putting a little piece of TPU in there to give it the spring it needs back into it, you will see that the joint will be restored to new-like conditions and will maintain that tension on the joint pretty much indefinitely. See that? Just like new. First, we're going to take a little bit of super glue and put it on the outside of the nut, and then squeeze it into place with a pair of pliers until it's flush. Next, we're going to take those sand pliers and crush the pre-built supports and remove them. They just rip right out. Don't worry about that. They clean up pretty easy. And finally, we are going to pin the shoulder plate strut to the shoulder joint. And everything snaps together. Okay, so here we're going to mount the lower weaver to the upper weaver, but there is a trick. We need to make sure that we cross pin it, but the cross pin has to be filed so that it gives a nice snap when you put the new weapon or arm on. So we're going to file a little flat in there, and then we're going to put that flat up, and we're going to test it on the arm. And once it basically just goes over the edge and snaps into place like that, you're good. Then you're going to clean up your edge, and now you can swap your weapons out and they won't fall off. Putting the hands together is pretty self-explanatory, except there's one thing you need to know. The tip of the thumb is slightly shorter than the rest of the fingertips. Also notice between the wrist joint and the fingers themselves, there's a place where you can put a small piece of TPU, and that will create enough drag on those joints so that you can hold a position or hold objects with it. Here's an example of how I like to get the TPU in there. That woodworking tool set that you saw in the beginning of the video I purchased off of Amazon. They've got a flat edge tool, and that's perfect for clipping it off right where you need it. Or you can use a pair of clippers, your flat edge clippers, and a pair of tweezers or needle nose pliers to get the TPU in there as well. So you can see now how with the TPU in there properly cross-pinned, there's a lot of resistance in the movement of the fingers to be able to grip and hold things. Now I'll show you how the rest of the hand is assembled. Now, although it is a lengthy and somewhat complicated process to putting these hands together, but the final result is very satisfying. And lo and behold, you have now the arm. Alright guys, we did it. We successfully made our arms for our Caractacus. Be sure to tune in next time, then we're going to be doing the legs. If you like what you saw here, you know what to do. And remember, never skip arm day.